Welcome to our comprehensive tutorial on implementing a 3D dungeon crawler using Java. In this series, we will explore the fundamentals of 3D graphics, user input handling, and game mechanics. Let's dive in. Before we begin coding, let's set up our development environment. Ensure you have Java JDK installed along with an IDE like IntelliJ IDEA or Eclipse. We'll also be using a popular Java 3D library called JMonkey Engine. To set up JMonkey Engine, head over to the official website and download the latest version. Follow the installation instructions provided on the site. Once you have JMonkey Engine ready, create a new project in your IDE. Let's start by creating a basic 3D scene. In our main class, we will set up the necessary configurations for our application. In this code, we create a simple application extending the simple application class provided by JMonkey Engine. The simple-init-app method initializes our 3D scene with a blue box. Run this code to see your first 3D object rendered on the screen. Great! Now our box is displaying. Let's enhance our scene by adding a camera. To give players a better perspective of the dungeon, we will position the camera above and slightly angled towards the center. With these lines, we position the camera at 0, 5, 10, and make it look at the center of our scene. This will emulate a player's viewpoint in the dungeon. Run your application again. Next, let's add some terrain to our dungeon crawler. We'll create a simple floor to make our box appear as if it's sitting on ground. Here, we're creating a larger box to represent a floor. It's essential to keep everything scaled correctly for a better illusion of a 3D environment. Let's run the application to see the floor below our box. Now that we have our basic scene, it's time to implement basic movement controls. For a dungeon crawler, we often need to be able to move the camera based on user inputs. In this snippet, we listen to input events and adjust the camera's position based on user inputs for forward, backward, left, and right movements. It's important to consistently run the input manager to properly register these commands. Next, we need to set up key mappings to trigger those movements we just defined. This is typically done in the simple-init-app method, where we assign keys to movements. We've assigned the WASD keys for movement. This is a standard approach in 3D games as it's widely understood by players. Be sure to test this out in the application. To give players a sense of immersion, let's implement a simple lighting solution. We'll add ambient light and a directional light to our scene. Here we create an ambient light to provide general illumination alongside a directional light that simulates sunlight. These additions greatly enhance the mood of our dungeon crawler. Let's create some walls to define our dungeon. We'll set up some box geometries at specific positions to serve as walls. This will give our players boundaries to move around. In this section, we create wall geometries using the box shape and manipulate their positions to create an enclosed space resembling a dungeon. Make sure to run the application and check the layout visually. Now let's add some functionality for enemies or NPCs in our dungeon crawler. We'll start simple by creating an enemy that moves back and forth within a defined area. Here we define an enemy class. This class moves back and forth on the x-axis. We'll call the move method in our game's main loop to have the enemy move continuously. To integrate our enemy within the main class, we need to create an instance of our enemy and update its position in the simple update method, which is called every frame. In the simple-init-app method, we instantiate our enemy and attach it to the scene. The simple update method is where we continuously update the enemy's position based on the logic defined earlier. Now that we have a moving enemy, let's add attack functionality. We want the player to be able to interact with the enemy. We will implement a simple collision detection and check if the player is within a certain range. In the check collision method, we check if our player's bounding volume intersects with the enemy's. If they do, we can implement a logic that will handle damage or interactions between them. Next, let's create a visual for the player. We will add a sphere representing the player character in the scene. This will give the player a visual representation in our dungeon environment. Note that we colored it red to differentiate it from the box and other geometries. To complete our player's capabilities, we will also implement a health system. Each time the player collides with an enemy, they would lose health points. Here, we define a method to handle damage. When the player collides with an enemy, the take damage method would be triggered to reduce player health and potentially lead to a game over scenario. Next up, let's create a simple inventory system. This will allow our player to collect items in the dungeon. We've set up an inventory list where we can add items and display them. The display inventory method will print the names of our collected items in the console. Let's create an item class to represent collectible items in the dungeon. Each item will have a name and other properties that you can extend. Our item class is pretty straightforward. It only contains a name for now. You can add more properties like type, effect, or value as required. Let's create some instances of items as we implement the collection logic. We can call this code in specific event conditions, such as collecting an item after an enemy is defeated. Test it out by implementing item collection after defeating an enemy. As we build our dungeon crawler, let's enhance the aesthetic aspect by loading textures for walls and the player. Instead of plain colors, we'll apply some textures available in the JMonkey engine. You'd also need to ensure the textures are present in your project's assets folder. This will significantly improve the visual appeal of your dungeon environment. Now that our basic game mechanics are set up, it's time to consider implementing a scoring system. It will add depth to your game by rewarding players for progressing through challenges. Each time the player collects an item or defeats an enemy, you can call the increase score method to track their score adequately. This feedback loop encourages gameplay. As we refine our dungeon crawler, consider expanding with additional features like sound effects and animations for a more immersive experience. JMonkey Engine supports audio playback, and adding sound cues enhances player interaction. With sound effects, you can create audible feedback for actions like collecting items and defeating enemies. Ensure your audio files are properly loaded in your assets. Finally, let's implement a simple game over screen. If the player's health reaches 0, we would need a way to inform them that the game has ended. This game over condition will provide a final check each frame. The game can either restart or exit as needed. By enhancing the user experience with graphics and sounds, you can provide engaging feedback to players. Now that we've implemented all these features, it's time for a recap. Today, we've successfully built a functioning 3D dungeon crawler with basic game mechanics including movement, enemy interactions, a health system, and an inventory system. Don't forget to customize your game further. Add more functionalities, design intricate levels, or introduce unique enemy behaviors. The possibilities are endless. Thank you for following along with this tutorial. If you enjoyed it, be sure to like and subscribe for more game development content. Leave your comments below about what you'd like to see next, or share your dungeon crawler experiences with us.